So let's talk about a special type in Java, which is called an object reference data type. So of course we all know that primitive data types such as byte, short, integer, and other types are those types that understood and processed directly by our chip, by our CPU, and CPU commands can understand these data types directly. That's why they're called basic data types, fundamental data types, or primitive data types. Unlike data types with objects such as class customer, we need to be able to locate the entire object in memory. And for this, we need to know what its location. So when we use objects, we start using object references. Object reference is a variable which stores location of the object, and we have to initialize it by using the new operator in our example. And so now once we have it, we can start calling operations. Now notice that the object is made up of its data attributes. Right? So the object is really made up of these data attributes. These data attributes occupy memory. And of course, integer is like 4 bytes in memory, another integer, and string is another object, which may be whatever, I don't know what the size of the string is. It can be multiple bytes in memory. But essentially, these 3 data attributes define the size of an object. So how about methods, including constructors? So the methods like our constructor right here, right? So when it's compiled into executable program, and our operations get phone number and print right here. So these are 3 operations that we decided to add to our class so far. These operations do not take space inside the object. Okay, so this object reference is pointing to this object in memory, but its space, its memory allocation does not include these methods. Why this is the case? Well, because once methods are compiled, they are unchangeable. They cannot be changed. They just made up of certain instructions when they're compiled, right? So every method gets resolved into a set of instructions to be executed. There are no changeable, mutable parts. Everything, once compiled, it becomes like, hard-coded, if you will, just gets loaded into memory, and it's always the same. So when we create an object, we store reference to this object, and we keep track of this reference, so this way we can use this reference to call methods inside the object. So in this case, for example, print is right here, so we use print, and print is invoked like this. But print knows that it was invoked for a specific object instance. So this is why when we say get phone number and use the address, the print always has a hidden reference to the actual object for which it was invoked. Okay, so this print method has always access to the original object. So basically something that's called customer outside of this print method call becomes something that's called this. Okay, this keyword this is this hidden reference that always refers to the object instance in computer memory. So outside of the class, we use whatever object reference we decided to use right here. Inside the object, we use the keyword this to refer to the same instance. Because this gets initialized, it gets assigned the location of an object for which this print method was invoked. Okay, so outside we call it customer, inside it becomes known as this. And look, that's how we were able to, inside the constructor, the same thing. Constructor is a method, and it gets invoked when we say let's create new customer object. And so inside the constructor, we use the this keyword which gets initialized already by the new operator, and it's pointing to the location of our object in memory. Okay, so this is something special to know for all of the operations, that this keyword plays an important role, that each method inside the class, including constructors, can refer to the location, can refer to the actual object in memory for which it was invoked. So this is true for print, we can use this keyword, and this is true for the customer. I'll give you a few more examples right here. For instance, we could have, with get phone number, we could have set this get phone number, okay? And likewise, we could also say this address. That would just, like, you know, make the use of this keyword explicit inside of our code. But this is unnecessary, because if we don't do it, because this is just too much wording, too verbose kind of version. So if we don't use this, then compiler understands that the print is a method inside class name customer. So if this is not a local variable inside print, and of course it's not because it's even using parentheses, it starts looking for this identifier inside the class scope. And of course it finds get phone number, and of course the list of parameters, which is empty, matches this list of parameters. So the compiler understands that you just want to call another method in the same class. Likewise, when it sees address, of course address is not a local variable inside print, but because print is a method of this class, the compiler starts looking for address on the list of the data attributes present in this class, and it finds address right here, so it's a string. So then it is capable of resolve the entire expression that constructs this string that we want to print. Okay, so these are just examples of how things are resolved. And of course, reference data type is what we use to refer to objects in Java. So this keyword, this, is an object reference to itself in memory. And when we create objects in our code, like with this customer situation, we decide how to name our object reference, and this object reference we hold on to so that we can talk to our object and tell the object what we want to do with it. Also, as soon as we lose this reference, for instance, if this was not the main method, if this was done in a different method and we return from that method, so this object reference was a local variable. Let me demonstrate. So let's say void demo. Okay, and inside this demo, I'll just simply take my code and place it inside demo, just like this. Okay, and instead of doing all of this directly here, I will call demo, and of course, because main is a static, I'll make my demo also public and static. Okay, so this way, because it's static, main will be able to call it. So now all this work is done not directly inside the main method, but in a method named demo. But the point is that as soon as we return, as soon as we reach the end of this method named demo, and we return back to our main method, so we could do more things over here, this customer object reference is a local variable inside this method. So as soon as we return from here and we continue with whatever we do in main, this reference is lost because all local variables are destroyed as soon as we return. And therefore our connection, okay, our connection with this object, okay, this is our object in memory right here. We know that we created by new, and customer gets a reference to this object in memory. But as soon as it's gone, so the customer now is gone, so our code loses connection to this object. As soon as this happens, in Java Virtual Machine, there is a dedicated thread of execution that basically looking for orphan objects like this, and all objects that no longer have connection, no longer have references to them, considered to be garbage, considered to be something that needs to be deallocated and returned back to memory. So eventually, at some point after we return back to main and this method call is complete and we no longer have this connection, this object will be garbage collected, which means that its memory will be deallocated and returned back to the operating system. So we don't have to waste memory simply because we just once created it. It's called automatic garbage collection, and this is the code that Java compiler makes for us. Okay, so this is how objects are deallocated in Java. They're deallocated automatically when we say we no longer use or we no longer have any references to these objects. So this is also something specific to the idea that we have reference data types in Java programming language.